Good afternoon, AP Physics 1 students. I am Lamine, 10th grade student, and this is
Jeffrey McLeod. I'm also a 10th grade student in AP Physics 1, and today we'll be teaching you guys about momentum and impulse. As you see on the board, we have the formula for both. The formula for momentum is P equals mv. This means it's the product of the system's mass times the velocity. The unit for momentum is kg/ms. Momentum is also a vector quantity, meaning it has direction and magnitude. This is very important when looking at this topic. In simplest terms, momentum means forward movement or progress, particularly when building strength and force as something moves forward. What is impulse? Impulse is the change in an object's momentum. This can be calculated by multiplying the net external force by how long it lasts, as seen in the formula, F net times delta T, which is also equal to delta P, which just represents the change in momentum. The unit for impulse is Newton seconds, which is in the same field as momentum. Next, we'll show you guys the inelastic and elastic collisions. First, we have to know what is an elastic collision. In an elastic collision, there is no net loss in kinetic energy as a result of the system. As shown on the board, the initial momentum is equal to the final momentum, as represented in the equation, m1 times v1 plus m2 times v2, which is the initial velocities, which is equal to m2 times v2f plus m1 times v1f. This just represents that final momentum is equal to the initial. As long as there's no outside force or an impulse on the system, there's no change in the system. So that means final momentum is equal to the initial.
what is an inelastic collision? An inelastic collision is a collision in which the kinetic energy of the system does not equal zero, and there is a change in kinetic energy. Typically, the kinetic energy is converted into either heat or sound after the collision. The momentum remains unchanged, and P before is still equal to P after. However, usually, the mass of the first object, if we were to look at the formula, m1 times v1 plus m2 times v2 is equal to m1 plus m2 times v. This would usually mean the first mass is at rest, the second mass is moving. And when they collide, they stick together, so they'll have a larger mass, as you can see, as they're combined, and they'll move at a slower velocity. One will move fast, then as they collide, some of the energy may be converted into sound or heat, then they move along at a slower pace.
Now let's begin with an inelastic collision. For this collision, I'll be using two carts labeled A and B. They have the same mass. I'll also be using a track with a stopper at the end, and at the other end, a motion detector to record its velocity, and a distance to tell me the numbers for the velocity and the position as traveled. I will have cart A start at rest at the beginning, and cart B at rest as well, near the center. I will apply a force to cart A to give it an initial velocity, and when I click play, it will record the velocity that's transferred onto cart B. In the lab quest, it shows that it starts at its constant position of 0.6 meters, and then once it collides, it gains a negative velocity, and its position slowly starts decreasing as it travels toward the motion detector. So what this means is that the velocity from cart A is perfectly transferred over to B, since when it collides, cart A stays at rest after the collision. And this basically just demonstrates that final momentum is equal to the initial momentum, as long as there's no outside forces or impulse acting on the system. As shown on the lab quest, you can see that it starts at rest, and once it collides with the other cart, you can see its velocity start to decrease as it travels towards the motion detector, and kinetic energy, there's no net loss.
Okay, I will be demonstrating an inelastic collision. As my partner previously said, these are carts A and B, and they have the same exact mass. This is my motion detector, and this is my lab quest, and I'll be using this to calculate the data for how these are going to move. As you could see from this demonstration, cart A collided with cart B and lost some of its velocity as they stuck together. They proceeded to move along the track at a slower speed than cart A had initially been moving, and moved along until they hit the motion detector. From this, we can clearly see that the velocity of cart B was constant until it collided with cart A, and it slowly moved along at a lower speed than cart A had initially been moving. This is Lamine,
And I'm Jeffrey.
and thank you for watching our explanation and illustration on elastic and inelastic collisions and momentum and impulse.
I'm Lamine.
You're not Lamine. Okay. Alright, I'm Lamine.
I'm Jeffrey.
Alright, you can't say it with a laugh. Okay,
I'm
okay, no way, bro.
Yeah.
I'm Lamine and I'm Jeffrey.
And I'm Lloyd.
And this has been alright, and thank you for watching our
You even say
hold on.
your story. Why you say hey, thank you for watching?
Bro, I'm not bro, did you start the video?
It's recorded.
Okay, so so unstart the video.